Welcome to the RE channel, brought to you by Space Level RE. Our mission, empowering engineers to manage space products. My name is Tod Redick. This two-part video covers Case Study 2, which was taken from the book titled The Responsible Engineer. That book is a foundational component of Space Level RE activities. It contains several case studies, each of which share important experiences and lessons. Also, the RE channel contains numerous videos which together provide a better overall understanding of Space Level RE's lessons and objectives. To keep videos of preferred durations, Case Study 2 has been broken into two videos, Part 1 and Part 2. This is Part 2. It would be beneficial if you had already watched Part 1. It covers some introductory manufacturing considerations which lay the foundation for a better understanding of Case Study 2 investigation and lessons. Then this video, Part 2, goes into the case study itself, then concludes with additional business considerations. Part 1 led us up to this Venn diagram. Here we are simply showing that risk from three different groups, or in our case, processes, can be common to one part, and that the combination of risk on a part increased the chance of part failure. Recognizing that it often takes multiple changes or risks converging for product failures to occur is crucial for successful product management. This is not theory. This is what experience and empirical data have taught us. But talk is cheap, so let's look at Case Study 2 and viewer can decide for themselves. Case Study 2 involved numerous high-power geosynchronous satellites losing small amounts of power. The losses were typically abrupt and fairly close in magnitude. When first detected, the amount was small enough that completion of mission was not deemed at risk, and general feeling was they were more of an anomaly than a systemic product issues. But as additional satellites and power losses occurred, concern increased. Though the impacted satellites still had sufficient power margin to complete the mission, the issue was elevated to an FRB or Failure Review Board level, triggering a full investigation involving regular meetings, root cause updates, and inclusion of customers. All satellites were in orbit, therefore we only had minimum telemetry to extrapolate from. The possibilities of root causes were immense and complex. Setting aside the space environmental possibilities and even conspiracy theories, there were many products and systems under consideration, which meant an extensive supply chain and many processes. And being a primary responsible engineer for supplying the satellite power, I was tasked with overseeing the investigation, therefore had to consider them all. This last one is important to notice. The engineer is always and should be the person contacted when product issue develops. I will comment more on this in a moment. This was a difficult and enduring multi-year investigation. Here's what we learned. This is book figure 1.7. It is the Venn diagram showing the four risks identified during the investigation. Let's first take notice of that point alone, 4. It took 4 risks converging to introduce the risk of product failure. Risk 1 was a new part and process that were added to the heritage product. One step in this new process was not tightly controlled, which introduced a spectrum of possible damage to the product of an earlier process. The potential range of damage was none too significant depending on the technician and equipment. Ironically, the new part and process were added to protect the heritage product. Then risk 2 and 3 were simultaneously added due to a spacecraft design change. Risk 2 was introduced due to the design change increasing available power. Risk 3 was a new part of slightly different configuration than Heritage. Both these changes of risk were approved design changes. By themselves, they looked very low risk. Then there is risk 4, inadequate team communication. This is an important one, but let's look a bit more at risk 1 through 3 first, then we'll get back to risk 4. Creating a timeline for risk 1 through 3 clearly shows some key interesting, possibly considered disturbing findings. I'll point out 3 key observations. Observation 1. We see risk 1 was introduced, yet multiple spacecraft were built and launched with risk 1, but had no power losses. So even though I consider risk 1 the primary technical root cause of product failure, nothing happened with it alone. Power loss only occurred once risk 2 and 3 were there also. Though the changes at risk 2 and 3 by themselves seem subtle and were easily approved, that slight change shifted their data sets or Venn diagrams to now overlap with some data points in the previously dormant risk 1. In other words, it took the changes at risks 2 and risk 3 to expose risk 1, which when combined could cause product failure. Observation 2. Failures were not immediate. It took additional space environmental exposure before the product failures appeared. That means they still worked on the ground, which would have made detecting the compromised product difficult. Observation 3. Risk 1 compromised the product of an earlier process. So even if you had a controlled process, even with tracked data on the Heritage product, risk 1 at a later time would have impacted that earlier product or data. Usually common cause variation and special cause variation are viewed as the result of a process on a product after that particular process. But this one is different. Here a process affected the product of a different earlier process. So even with configuration management in play, this scenario would still be difficult to identify. The story of risks 1 through 3 is quite interesting, but it was hard to figure out. Now risk 4, inadequate team communication. In this case, we quickly identified risk 1 once we more aggressively pursued proactive direct interaction with the supply chain technicians. Identifying that process flaw allowed us to link together all the risks, creating a valid failure theory. Now with a theory, we could attempt its validation. Having had key roles in numerous investigations besides years of project management and upper management experience, I can confidently say proactive communication is at least as important as any other product risk variable. The book often discusses how proactive communication must be a requirement among stakeholders and supply chain, and it is one of the foundational requirements of Revis. So what basic knowledge would be needed to identify root causes or risks and understand the linkage of variables? At a minimum, knowledge of requirements, design, history, and manufacturing. Immediately and clearly, we recognize there is only one person who has or should have that knowledge. It is a properly trained RE, and that RE must have proactive communication with all stakeholders, vendors, and supply chain. Only with these skill sets and proper environment could a RE not only solve issues, but also prevent product issues. Though I presented these categories in a simple sounding and looking format, there are many additional difficult and often tedious tasks that accompany them. Some examples include acceptance testing, revision control, vendor or supply chain management, contract empowerment, process vetting, ITAR versus commerce, proprietary information, technician training and verification process, etc. All that takes hard and smart work. Acknowledging and pursuing just these objectives will have many benefits all by themselves. And pursuing these objectives must be a company's foundational goals and requirements. Due to our experiences, like this case study clearly revealed, is why we engineers designed and successfully utilized Revis. It directly targeted these categories. The results were very beneficial in numerous ways. Let's discuss another repercussion of case study 2. Once we had a solid failure mechanism theory, we were able to design and build a test which successfully validated it. Witnessing the products fail as theorized, and in spectacular fashion, I must add, was quite a satisfying and memorable moment. But all that came with a cost, a financial cost. Since a company's goal is having a successful business, which usually means making profits, I must emphasize the very high direct cost of a product failure. It is already costly to identify root cause candidates, especially when the failures are in space. But then to also recreate the failure mechanism here on Earth, mimicking the conditions of how they failed in space, is very difficult, hence expensive. This particular investigation and testing involved thousands of man-hours, not to mention the special equipment necessary. The expenses could quickly annihilate a company's cash reserves. It is much less expensive to prevent failures in the first place. Case study 2 is a fascinating example of real life, but it is important to recognize that its key lessons are not an anomaly. Other case studies and experiences clearly reinforce its lessons. Real life naturally and regularly likes to make things challenging. For example, in another case study, supply chain technicians consciously altered the product, not with malintent, but believing it was necessary to do a good job. That change was one of the primary root causes which resulted in losing several $100 million to lost product alone. Again, proactive interaction and communication between a properly trained RE and technicians would have prevented those losses. There are also other negative business considerations when dealing with product issues. For example, from a RE perspective, I can personally vouch that being in these situations is very stressful and distracting, which results in adding even more risk to the operations. It also affects marketing personnel who are trying to negotiate contracts. I can guarantee that it is much easier to negotiate new, possibly even more profitable business if you have the customer's confidence. Companies' problems escalate when working in troubled, reactionary mode. The purpose of creating a video for Case Study 2 was to show a real product failure situation and what we learned. An essential fundamental lesson is that it clearly shows that an engineer or RE is best possibly only person to effectively manage product realization and ongoing manufacturing of critical parts or products. Recognizing that lesson and then supportively acting upon it is central for product and business success. The other case studies and miscellaneous lessons in the book only reinforce that. Acting solely on that has significant benefits by itself. Not only does that just make sense, but we have already proven it when utilizing Revis. But best chance of overall product and business success is created when the entire company and stakeholders are working in unison. To accomplish that requires significant knowledge, leadership, tools, and resources. A good way to begin to get an understanding and appreciation of those needs is to look at a roadmap of book content. We have already mentioned the case studies, which show that proactive RE involvement is necessary. Next, we see Revis. As mentioned earlier, that is a system we engineers design and successfully utilize to proactively manage our responsibilities. It is also a great starting point for designing a quality management system or QMS. Then we see numerous subjects which reinforce or expand into other topics important for long-term success. In fact, they make up the bulk of the book. For example, we see QMS. That topic alone is huge and diverges in numerous directions, including significant material on standards, related organizations, and their tools. Then there is material to capture the importance of configuration management and project management. It then introduces Design for Six Sigma and Lean Six Sigma as example tools for those. Their purpose is to eliminate product variances and reduce waste. There are other tool options. I chose these due to their heritage, significant supportive resources, and sound logic. Then we see the satellite industry. There we discuss the robust growth of the industry, which is good, but those opportunities will also attract competition. Therefore, companies will need optimized resources and high product confidence to compete and be profitable. The final book subject is promoting the creation of a standard specifically designed to teach REs important skills and successful management of their responsibilities. Companies which have REs skilled with these items listed in this chapter will have a significant advantage over companies who do not. As one can see, the best chance occurs when individual engineers, all company departments, and related organizations and supply chain are working in unison. Those same roadmap topics could also roughly be used as a guide or logic path if a company wanted to learn or assess implementing Space Level RE material. For example, does the M.S.E.E. exist, or is it being utilized for maximum benefit, such as risk identification? How is RE involved? Are they empowered? How? What is present QMS or plan? Is company targeting QMS certification? It is essential to understand that QMS standards are only guidelines or requirements. They are not a functional QMS. It is up to the individual users to design their own QMS. So the risk here, which we have directly witnessed, is that a company can have a QMS which gets certified, but that their QMS does not adequately mitigate risk for their particular product or company. Then what is the plan and tools for configuration management and project management? That is from requirements, product realization, through ongoing production. In regards to satellite industry business considerations, as industry continues to trend away from specialized industry, which is often more forgiving, toward common product? Is the entire team, including supply chain, linked or empowered for optimization? How is customer confidence addressed? The proposed RE standard could also be used as a reference list of skills to pursue, and then how and what tools to achieve it. All those considerations could be pursued independently, and we are attempting to provide significant material through the book and videos to encourage and achieve that. Though Space Level RE also offers direct interaction as much as our resources can support, should a company or institution want an initial evaluation and strategizing session. This concludes Case Study 2, Part 2. It clearly shows why our mission is empowering engineers to manage space products. Don't forget to watch other videos here on the RE channel. 2 other videos which would provide a more comprehensive understanding of Space Level RE and its activities are 1, Space Level RE Introduction, and 2, the Responsible Engineer Introduction. And check back regularly for new material. Viewer feedback is appreciated and can influence future activities. Also, please like and subscribe. This helps keep the material on the channel going. Goodbye and have a great day.